Good morning, guys. My name is Bamsheri Sampson. I'm the e-tutor for CSC 206 Human Computer Interaction, and this is Section 3, Course Unit 4, System Interactive Design Pattern. The introduction of the course still remain the same thing. The objective still remain the same thing. But the learning outcome of this Unit 4, it is expected at the end of the class that the student should be able to know the guides for developing effective design patterns. Students should be able to understand the process of design and then to be able to describe various screen design and layouts, and to also know how to design acceptable presentation and understand prototyping. Introduction. System interactive design pattern. A pattern is an invariant solution to a recurrent problem within specific context. An human-computer interaction design pattern is an approach to reusing knowledge about successful design solution patterns do not exist in isolation but are linked to other patterns in languages which enable complete design to be generated. So, characteristics of patterns. This include capturing design practice and not the theory. It also, secondly, capturing the essential common properties of good example of design. The pattern also representing design knowledge at varying level of social organization and conceptual framework, embodying value and expressing what is made in interface design. The patterns are intuitive and readable and can therefore be used for communication between all stakeholders. One of the characteristics is also a pattern language should be generative and assist in development of a complete design. Guide at developing effective design pattern. That is, there is a guide that you can use when you want to develop effective pattern. Commencement of design process. The human interactive designer should commence its design process by asking the following question. What is design all about? What are the interventions? What are the goals? What are the constraints? These are questions that a designer must ask when developing a pattern. He must at least familiarize with himself with all the necessary questions. Then the second one, design process. What happened? When? Then the user. Who are the users? So because if you can identify the user, you'll be able to streamline the patterns. What are their likes and dislikes on interactivity? Navigation of interaction. How does the user find its way around a system? Design consideration scenario of interactions. Part of the scenario is a probe of rich stories related to design issues that include user experience and expectations. Iteration and prototype. Remember that the designer never gets it right the first time. Iteration and interventions. The designer should design interaction, not just interface, and not just the immediate interaction because technology changes. Designer should design interventions, not just artifacts, and not just the system, but also related documentation such as manual and tutorial. What is design? This is the first question that a designer must even familiarize himself with. Design is achieving goals within constraints. So, design should consider those to benefit from the goals and for what purpose. The design should consider the constraints in terms of materials and platform and the corresponding trade off. The golden rules of design is for the designer to understand its material for human computer interaction understanding. The material means understanding computer limitations, its capacities, its tools, and platforms. It also means understanding people, their psychological and social aspects. The design should consider the possibility of human error and their interactions, since to err is human, to err is human example. The example of accident report on air crash, industrial accident, hospital mistakes reveal the inquiry blaming human error on all. But concrete lintel break because of too much weight applied on it. So the blame goes to the inter error, not design error. Since we know how concrete behaves under stress, so human error is normal, and we know how user behaves under stress. Hence, design for it treats user at least as well as physical material. The central focus is the user. What they are trying to say here is that for every design, there's always a constraint, and a designer must understand that constraint against his own material, that is available resources that he has for computer human interaction. He must understand that. Then he must understand the psychological and social aspect of it. And he must also consider the possibility that human will always commit mistakes, they will always make errors, and he should treat human as what? He should treat he should treat he should make the user a central focus. He should treat it like his own material. So design life cycle. Look at this little image here, which at least interprets the design life cycle. What is wanted? That is, this is information gathering for system requirements. You can gather it through questionnaire and you can gather it through interview. That's why they say interview entograph. What is there and what is wanted. Then scenario task analysis, meaning meaning you will now look at the possibility of what is expected. Then you analyze all those areas that design is going to be centered on. Then design itself, the guidelines principle, that you are going to at least collate, then turn to rules, because once you use those guideline principles, it becomes a rule in your design. Dialogue, notation, prototype, and evaluation heuristics. As you are designing, you are evaluating in that process so that you will be able to make corrections, subject the system to test, then before you now go to the implementation stage. Implementation, debugging, and testing takes place in all those areas. Architecture documentation helps. Then you must document all the systems so that all the other designer that comes after you, they'll be able to take and improve on what has been designed. Explanation of process in the diagram. Requirements. This identifying what is there and what is wanted. Then analysis. This is ordering and understanding. Then design. This concern. So these are what I've been able to explain. Structure and prototyping and implementation and deployment. Design process. Continue. To carry out the above, consider the limited time available as a design, the usability. Find out problems that trade-off may work against the ultimate usage of the design iteration and ensure such problems are tackled right from the onset. Remember that a perfect system is one that was badly designed. So do not expect to design a perfect system. Systems are dynamic. That is, your design can't be perfect from the onset. Find out the problem that can hinder those designs and address them from the beginning. You understand? So don't expect that whatever thing you want to do can be perfect. Systems are always designed. Then just find out a problem that is possible for you to trade off at the beginning. User focuses. It is essential that you know your user, their personality, and cultural probes. Talk to those class of users, watch them, and use your imagination of their perception of the system they want. Innovate a user model, not necessarily a real person, but carry out a prototype of a system. The user that you are designing system for, you need to find out about them, what they want, what they like, what are they using, so that whatever thing you are modeling, it will be suitable for that user. And another good thing is that you don't necessarily have to see a woman. You can model a prototype to be able to get what you are intending to design. Design cultural probes. Cultural probes can be carried out as follows: by direct observation, though sometimes hard, for example on psychiatric patient, by giving out probe packs that consist of items to prompt responses. These are given to the people to open on their own environment and to record what is meaningful to them. These probes packs are used to inform interview prompt ideas and en route and culture designer. Gather stories for the design are used and reused. By communicating with others to validate model and understanding dynamics. Finding out what we user want to do by step walkthrough on what they can see using sketches, screenshots, etc. What they are used to doing, e.g., manipulating keyboard and mouse, etc. Find out their thinking on the proposed interaction design. Explore depth by exploring interaction to determine what happens when exploit cognition no exploit cognition to determine the user's thinking. Explore architecture of system to determine what is happening inside. Then express dynamic through screenshots, appearance, and scenario behavior. Use several scenarios and use several methods since scenario provide one linear path through system design. Example of personality probe for a design. Shola, okay, let's take this scenario. Shola is 37 years old. She has been the warehouse manager for 5 years and worked for engineering company for 12 years. She didn't go to university but has studied in her evening for business diploma. She has 2 children, aged 15 and 7, and does not like to work late. She did part of an introductory in-house computer course some years ago, but it was interrupted where she was promoted and could no longer afford to take the time. Her vision is perfect, but her right hand movement is slightly restricted following an industrial accident 3 years ago. She is enthusiastic about her work and is happy to delegate responsibility and take suggestions from her staff. However, she does feel threatened by the introduction of yet another new computer system. The third in her time at the engineering company. Design this navigation design. Within local structure, utilize a single screenshot. Within global structure, utilize a whole site. Level of design to guide designer include widget choice level, containing menu, button, etc. Screen design level, application navigation design, and environment design level that comprises other application and operating system. Examples of web design. A web interaction design. The widget choice level contain element and tag, e.g. something like this. The screen design such as page design. The application navigation design such as site structure. Then the environmental design such as web, the browser, and external link. The physical device interaction design comprises the widget choice level comprising the controls such as buttons, knobs, and dials. The screen design such as the physical layout. The application navigation design such as the model of design. The environmental design such as the real world structure of design should be viewed from the following platform within a screen. Locally looking from one screen looking out, then globally from the structure of the site and movement between screen within the application and a wider still consider relationship with other applications. Then the 4 golden rules of designs are knowing where you are, knowing what you can do, knowing where you are going or what will happen at you have done. Then knowing where you have been and what you want to do. Example of where you are of a website address, showing paths through the website. See where you are websites, top level categories, then subcategory, then this is the page. Meaning that the address is pattern driven. So you have to follow that pattern. What they are saying, yeah, when you are in a website, it follow a certain pattern to get to where you are at the page. This link to higher level. Then the following hierarchical diagram is how part of application with screen or group of screen typically shown in a function separation. The system, then info and help, management, message, add user, remove user. Drawing navigating hierarchies enable short-time memory but not the menu size screen. It also shows menu items on each screen with the item structure within the dialog in user interaction design and system, but detail differ in each. The network diagram show different paths through system, including branches that are more task oriented than the hierarchies. It shows the relationship between applications and beyond. See the illustration, mainstream, user, and confirmation. Network diagram show what led to tonal branches and is more task oriented than hierarchies. When considering style issue, it ideal network diagram also identify. 45 platform standard and consistency international issue such as cut and paste, and 2 embedded applications and links to navigation issues such as design and layout are the grouping of data that the screen displays. A use of white space to separate group of data is also recommended as in doing. It should take of what information should be displayed. The design should ensure that form follows function or what happens when it shows functional diagrams. The applications such as the web browsing. Principle of design. The basic principle in the screen structure, order, and their alignment shown in the diagram below. The designer should ask what is the use, the order of display, and possible com display. The grouping and just look at the display. Then from the diagram above, one can distinguish items that are logical together as against those physical together. It is from the diagram above that you can now see the order of grouping in the diagram below. Billing, name, address, card, order details, item, size, delivery details, name and address. So it is important and should be considered in the design. This think about what is a natural order. The order should match the screen order. Use boxes, space, etc., and set up the light tabby. Decoration, using buses to group logical items. Use fonts for emphasis and endbets, but this should not be too many. Consider the best method to align items. For example, you can separate items using white space as in the examples above. Alignment of thesis. This is very, very important. We all do it in our when we are doing, maybe when we are using CorelDRAW or when we are using Word or even this PowerPoint too. You have to align thesis so that at least it can be readable for the user or for your audience. So these are purpose driven when you are creating your patterns. So look at the examples here in this diagram here. You align thesis based on their correspondence. Screen design and layout. Look at it. Look at the way we do it here. Especially think. Look at this. You align thesis. Look at just the way it is done. So presentation and physical control of data. So just look at how the grouping and ordering is done here. It is very detailed enough for every user to be able to understand. Here are the items of same function are grouped together. In other words, in order of priority of functions. This is what you see in this forms and dialogue boxes. In designing forms and dialogue boxes, the designer should pay attention to presentation of the form and dialogue box. It should also consider how data will be entered into form. It should consider the importance of similar layout issues concerning the form and dialogue boxes, such as alignment and the label length. In presenting an effective logical layout, the designer should use task analysis and appropriate grouping in natural order for entering information, such as from top to bottom, left to right, depending on the culture adopted, and setting tab order for keyboard entry. Presentation and physical control of data. Look at the illustration. The first one, you see that it was scanned. Then the second one, look at the separation of Alan and this with space. And the address was also what? Very structured. Then the last one is also questionable because it's more or less the same. So you have to structure it in such a way that at least the boxes or form is in the middle. The second present an acceptable arrangement. The designer should indicate which and what area is active and passive, such as where the user should click and where to type. The styles used should be consistent, such as in the web underline link. The label and icon should have standard for common action. The language used in the label should be bold and should represent the current state and action. Creating avoidance in design. The word avoidance is a psychological term used for physical objects. The shapes and size of the object suggest actions to be taken on the object. Actions such as pick up, twist, and throw. So, in a user interface terminology, one can say that buttons avoid pushing depending on their state. For screen object, the button-like object afford mouse click, while the physical-like object suggests use. There's a culture of computer language use such as icon avoid clicking or even double clicking. Presentation and physical control of data. So just look at the example here. Designers should design appropriate appearance for interface object to present accurate information. Aesthetic, utility, color, and 3D features could be added for appropriate usability. In presenting information, purpose matters. The purpose will enable the designer determine the sort order in which column will be data be input and whether it is numeric or alphabetic. Aesthetic and utility. Look at this. Aesthetically pleasing design increase users satisfaction, improve productivity. Beauty and utility may conflict. Mix up issues style. Easy to distinguish. Clean design, little differentiation, confusing background and behind text. Good to look at but hard to read, but can work together. E.g., the design of the counter to consumer product. Key differentiation, e.g., mark. Presentation and physical control of data. Aesthetically pleasing design increase user satisfaction and improve productivity. Beauty and utility may, however, sometimes conflict. Mix up visual style make presentation easy to distinguish. Clean design and little differentiation leads to confusion on the part of the user. Or example background behind text may be good to what? To look at but hard to read. Just like when I was reading in the that was previous slide, you can see it was very hard to read the content. Look at the illustration above. Both can, however, work together if carefully done, as demonstrated in the design of the counter in consumer product presentation. Using color and 3D in presentation. Both color and 3D effects are often used very badly. In using color, the designer should remember what other monitor have limited modern monitor have millions of colors to manipulate. Hence, color is overused abundance. The designer should also be aware of color blindness as a result of using too many, too many users sparingly in other. Both color and 3D effect are often used very badly in then look at what this explains what we are saying here. Look at it. Badly used. That's an example of what we are discussing. Then a bad use of color is an overuse of color without very good reason. E.g., kids, you do adjust your set, which may eventually adjust your monitor to cause color blindness. Poor use of contrast as occur when reason. So, e.g., kid use do adjust your sets. Or example, when you require changing interface gray, only you may not be able to read your screen. Across country and culture, there is localization and internationalization that are for simply change language, particular culture and languages. In globalization, when you try to choose symbols, e.g., that work everywhere, you realize you cease and let right order and use resources database instead of literal text, but changes are required on site, etc. Prototyping is an essential component of interactive system design. Prototypes may take many forms, from rough sketches to detailed working. Prototype they provide concrete presentation of design idea and give designer, users, developer and manager an early glimpse into how the new system will look and feel. Prototypes increase creativity, allow early evaluation of design idea, help designer think through, solve design problem, and support communication within multidisciplinary design team. Prototypes are concrete and are not abstract, hence provide a rich medium for exploring a design space. They suggest alternate design paths and reveal important details about particular design decisions. They force designers to be creative and to articulate their design decisions. Prototypes embody design ideas and encourage designers to confront difference of opinion. The precise aspect of a prototype offer specific design solutions and designer can decide to generate and compare alternatives. The imprecise or incomplete aspect of a prototype highlight the area that must be refined or require additional ideas. This is an example of prototype. Design, prototype, evaluate, okay done, then redesign again, prototype again, then reevaluate before you can now implement what you have been. In prototyping, you never get it right first time. So if at first you don't succeed, then continue. That is why you have the loop. So moving little by little, but you will, but to where? So need a good start point, then need to understand what is wrong. Pitfall of prototyping are designer need a good starting point, need to understand what is wrong. These pitfalls are avoided by Malvin's or the Matterhorn rules that say moving little by little but to know. So, in conclusion, design is an active process of working with a design space, expanding it by generating new ideas and contracting as design choices are made Designing effective interaction is difficult, and many interactive systems, including many websites, have a good look but a poor feel. The quality of interaction is tightly linked to the end users and a deep understanding practice. Designer must take the context of use into account when designing the details of the interaction. Prototypes are flexible tools that help designer envision a design space, reflect upon it, and test their design decisions. Prototypes are diverse and can fit within any part of the design process, from the earliest ideas to the final details of the design. Prototypes provide one of the most effective means for designers to communicate with each other, and as well as with users, developers, managers throughout the design process. So, to summarize this, the process of design comprises requirement, analysis, the design itself, interactions and prototyping, then implementation and deployment, and maintenance. Because during implementation, you are going to carry out testing and debugging, and when you now finally complete the deployment, you have to continue to maintain it in order to standardize that system. The basic principle is screen design and layout are the grouping of data that the screen display, the structures, orders, order, and their alignment. In designing forms and dialog boxes, the designer should pay attention to presentation and purpose of presentation. The avoidance is the time used to reflect on the shapes and sizes of physical objects that suggest actions to be taken on the object. Artistically pleasing design increase user satisfaction and improve productivity, while mixed up virtual styles make presentation easy to distinguish. The designer should beware of color blindness resulting from using too many colors. Colors should be used sparingly in order to do what? To reinforce other information. A bad use of color is an overuse of color without very good reason, and it may eventually cause color blindness. 3D effects are good for physical information and some graphs, but if overused can blur information. Prototypes provide concrete representation of design ideas and give designer, users, developers, and managers an early glimpse into how the new system will look and feel. This has brought us to the end of this lecture, though it is a very long lecture, but we thank God that at least we are able to wrap it up at the end of the day. This is the end. This has brought us to the end of section 3, unit 4 of the course courseware of computer no human computer interactions. Thanks for listening. We meet again in the next clip. Please read up. Please watch all the videos, then do all the exercise under the video. Thank you.